mega project in the port of Hamburg. It's the biggest double bascule bridge in Europe. Bridge building is the king of engineering disciplines. New construction on a historical site.
It's at Hamburg and is really a wonderful piece of engineering.
Nothing like it has ever been built since. Until now. It's a technical masterpiece. It even makes engineers break out in a sweat. Okay, here it comes. Then you're in crisis mode. Hamburg, Germany's biggest port. Over 8 million containers per year, 2,300 freight trains a week, and around 9,000 ship arrivals per year. Superlatives that have to be moved. Roads, bridges, rails, and of course the waterways. To me, personally, the most important thing is to ensure that the port runs smoothly. 11% of jobs in Hamburg are directly or indirectly linked to the port. The port means transport, infrastructure surrounded by water. Without bridges, there can be no port. The bridges are the arteries. The port is growing, and with it, the necessity to optimize the existing transport routes. Bridge building. It's hard to think of a more complicated job. A bridge is always at the limits of technology and the limits of efficiency-driven construction. And Hamburg has plenty of them. 2,500 bridges, more than Venice and Amsterdam put together. One of the most unusual bridges in Europe and the world is right in the middle of the port. It's a bottleneck for trains, trucks, and ships. It's the biggest of its type, and over 80 years old. It's a forgotten landmark of Hamburg.
We look at the greatest lift bridge on the continent. It's at Hamburg and is really a wonderful piece of engineering. The center section of the bridge is nearly 250 feet in length, yet it can be lifted to a height of 130 feet as easily as father lifts a glass, though not quite so quickly, of course.
What's special about the bridge is its size and its passage width. For a lift bridge at the time, it was really extreme. People are still arguing over whether it's the biggest or just the biggest of its type. It's very, very big by the standards of the time. These vast dimensions were built because ultimately, in the post-war period, they were needed. 80 years and one world war have left their marks. The old lady of the port can't be preserved any longer. She has reached the end of her life. It has simply become soft from continual use and heavy loads for which it wasn't designed. It's almost permanently in intensive care to keep it going. But really, it's on its last legs. It's more than just a piece of history. It's a bottleneck of huge importance for port operations. Responsible for the running of the port, the Hamburg Port Authority, an institution with a unique structure.
2005 ist die HPA gegründet worden.
The HPA was founded in 2005 from 4 different divisions. The aim was simply to avoid interfaces, to be the single optimal customer contact in the port, to lay the foundations for the port's success, so that customers can be successful because there is optimal management of the infrastructure, access routes, and a bit more traffic management and traffic control.
Verkehrssteuerung, Verkehrslenkung optimal passieren kann.
The HPA has been planning a replacement for the lift bridge since the early 2000s. Long planning for an optimal result. They didn't just pull a solution from a hat and say, oh, this is how we'll do it. There was a really long development process before they reached this specific construction. And it's also about how it looks.
Und das hat auch was mit der Optik zu tun.
A double-edged sword for the experts. a coherent infrastructure concept that fits aesthetically with the look of the port. The solution, at least as special as the challenge. A huge bascule bridge right beside the lift bridge. It's totally unique. It's a once-in-a-career opportunity. Not only unique, but also an asset for the port. The keyword, infrastructure.
Das Bauwerk bringt mit Sicherheit was für diesen Hafenteil.
The construction work will definitely bring something to this part of the port, because it will resolve the old dispute about the position of the old bridge and the tracks overhead, and because the road traffic will be on a separate section. Behind the mega project lies the idea of smart traffic management. When we remember the old bridge, we had road and rail on one single bridge. When the trains went across, the road traffic had to wait. We've resolved that. For me, that's a substantial planning achievement. And putting all that into a bridge which also looks attractive aesthetically, that's a technical masterpiece.
Ein technisches Meisterwerk.
At least that's the plan. May 2011, construction work has begun. Everything starts with the foundation. But first, the construction pits have to be made in the middle of the river. As soon as the excavators start working and construction begins, every day counts. You have to cope with the pressure, otherwise you shouldn't be building. A platform in the river is used to help build the excavation pits. Precision work with several tons of equipment.
Wir mussten mit schwimmendem Gerät rein ins Gewässer.
We had to get into the water with floating machinery. On this working platform, if I can call it that, there are drilling machines, which in our case placed 30-meter-long carrying beams into the Rethe River.
In die Rethe setzen.
Mud from several dozen meters deep meets high tech. The engineers must be extremely precise with the excavations. One mistake could destabilize the foundations of the Rethe Bridge next to it. The HPA has brought in experts from across Europe for the job. The biggest enemy, the schedule.
The worst-case
scenario would be finding a bomb. In Hamburg, there are still several aerial bombs from the Second World War. It shouldn't happen because a search for explosives was carried out to ensure that the construction area is free of explosive devices. But we also had areas of doubt on the shore where we actually found an English aerial bomb. Nothing happened, of course. Not an easy job. But something as simple as a rock can delay the schedule for one of the most modern construction sites in the city by months. No one could have guessed what difficulties the project would encounter. Construction takes place in parallel on both sides of the waterway, while shipping traffic is ongoing. Closing the area is unthinkable for the port and for Hamburg. It has been accessible for over 90 years. What was missing? A suitable bridge. At that time, it was the most important port extension area, and it had to be connected to the rest of the port, namely with the railway and the road. The plan: the biggest lift bridge in the world. A steel giant. Unique then, as it is now.
Bewegliche Brücken wurden damals auch nicht
They didn't often build moving bridges then. Big moving bridges were very rare.
Damals eine große Ausnahme.
March 2012. Construction work on the foundations for the new bridge is progressing well. Hundreds of tons of cement are used. steel is made pliable. As the bascule bridge approaches completion, the end of the lift bridge draws nearer. When the bascule bridge is opened, the lift bridge will be dismantled and will vanish forever. "90 years ago, in the same place. Its foundations were laid in the early 1930s. The construction process was similar to the one used today. The big difference is that more muscle power was needed. This was deliberate. The construction of the bridge was a way for crisis-stricken Germany to create jobs. So, was the bridge nothing more than a standard work creation measure?
Nein, das ist überhaupt kein Standard. Ich hatte mal Besuch.
It wasn't a standard. I was visited once by an American engineer who specialized in moving bridges. He said that this bridge was the absolute pinnacle of lift bridges. Nothing like it was ever built again.
Danach ist nie wieder etwas in der Art gebaut worden.
After a construction time of only 15 months, they opened a bridge that would stand for over 80 years and whose end is now near. December 2012. The leaves for the biggest rail bascule bridge in Europe. The HPA appointed experts from Bremerhaven to work on it.
Wir setzen Projekte
We implement projects, but of course we need construction firms, manufacturing facilities and materials, and we've got to pay for that.
Das müssen wir uns einkaufen.
Work on the huge steel leaves is nearly complete. The first milestone of this mega project, construction work with these superlatives, is only for the best.
Ja, im Bereich Stahl.
You can say that in the field of steel, we're working with the best in the industry. Slani, in the Czech Republic. They've been welding heavy steel here for decades. A production plant of the company MCE, a global player in steel construction, specializing in bridges.
Wir sind die Firma MCE Slani, 20 Kilometer.
We're the company MCE Slani from near Prague. We manufacture heavy steel structures. We manufacture bridges of about 200 tons per bridge, up to 10,000 tons. Welding, grinding, and constant checks. Centimeter-thick plates of steel are turned into bridge parts weighing several hundred tons that have to fit with millimeter precision. A single mistake would have serious consequences. Welding is a science in itself. What we can see here is weld binding. All the welding seams and corners are polished smooth with micro-milling tools. It's very important for the durability. For dynamically loaded structures, it's very important that there are no sharp corners or overhangs in the design. An overhang of millimeters could make a steel structure unusable in just a few years. The bridge sections for the bascule bridge were manufactured here. Each leaf weighs 640 tons. Superlatives that are fitting for Rethe. With a length of over 70 meters, the lifting part of the Rethe Bridge was the longest of its type anywhere in the world at that time. History repeats itself. The bascule bridge will also be the biggest of its type.
Die Stahlteile für die Brücke, das ist
the steel components of the bridge are the face of the structure. I can say that unequivocally. because these bridge parts are very delicate, despite their power, their great weight. They're really beautiful, and that's the special thing about the bridge.
Das ist das A und O der Brücke.
And now it has to be moved. It's not an easy job moving 4 sections that each weigh 600 tons. The drivers on the Autobahn don't need to worry. Appropriately, the bridge is transported by water. Assembled on land, the leaves are impressive, even for professionals.
Das erste Mal gesehen habe ich die
I first saw the steel bridge when it was just separate parts. They were huge, of course.
natürlich enorme Dimensionen.
With 16 axles and at walking pace, the huge structures move towards the water. It's almost impossible to turn. Every turn must be made with precision. The vehicle is steered by a joystick. But it's not easy.
Diese neuen Bauwerke,
These new construction works always have their particularities. It might just be a different site that creates different framework conditions you have to deal with. So each project is, in my view, unique.
aus meiner Sicht ein Unikat.
Heavy machinery lifts the bridge sections onto a pontoon. Then the journey begins towards the Rethe to Hamburg. Where they are eagerly awaited. The current bridge is past its prime, and that has been the case since 1943.
One of the greatest serial stories of the war, the battering of Hamburg. By night and day, the big German city was subjected to Allied air assaults without parallel in history.
During the wars, they destroyed the bridges first, as it was the quickest and easiest way to achieve the maximum impact. It's the easiest way to cut a transport route. The Rethe lift bridge was in a very important location, so they couldn't relinquish it, although it was very badly damaged. The main girder on the eastern side was almost severed by a bomb blast. The port of Hamburg, 1945. The old steel guidelines were in place at that time, whereby new steel, primarily steel with good weldability, was surrendered to the Allied forces, and old steel was used to repair bridges. That means old usable bits salvaged from totally destroyed bridges. That was also the case with the Rethe bridge. You can't build them like that nowadays, as bridges are all welded now. Rivet construction is much more tolerant in terms of damage than weld construction. With weld construction, if it splits, unfortunately the split can go right through. The Rethe bridge, built to last forever, but now its end is approaching. The last inspection of the construction site before structures weighing 5,000 tons are installed. The first leaves for the bridge arrive by water. Then, the heavy machinery work.
Das ist ein 1000-Tonnen Schwimmkran mit erheblichen...
That is a 1,000-ton floating crane, which is extremely large, of course, to raise the 640-ton bridge leaves. It was a really special moment for me in the project when the floating crane arrived on the building site for the first time. They don't have to wait long. The first leaf has arrived. Time is money, and an operation like this is always risky. When using a floating crane, you can't control the environmental conditions. They're not in your hands, of course. Strong winds are difficult when using floating cranes. And it's not the only difficulty. One of the biggest floating cranes in the world has to move several hundred tons of steel into place with millimeter precision.
In Gewicht ausgedrückt eine Brückenklappe
One bascule, without counterweight, just the steel component, weighs the equivalent of about 650 Volkswagen Golfs. That's about 640 tons. If the crane damages the parts of the foundation, it's a disaster. As the contracting authority, you follow it very closely, but you can't intervene because it's the contractual obligation of the contractor, and you don't want to disturb them at that moment because it's not something he does every day, and he needs complete concentration. There's a lot involved. The other leaves are prepared. The bridge parts are fixed to the crane with giant steel cables. For the journey to Hamburg, the parts were secured not with straps, but were welded in place. The giant sets off. Nothing must go wrong now until the bridge leaf is in position. All traffic was stopped on the Rethe for this operation, but not for long, so there can be no delay.
Nein, das geht einfach nicht. Man kann
No, you can't simply shut off important shipping routes in the port of Hamburg for a long period of time, because there's so much depending on it.
weil da so viel dranhängt.
And no one understands that. There's a principle in the port of Hamburg that everyone who works here soon grasps. The port needs to function 24 hours a day, 365 days a year. And the HPA does all it can to ensure that that happens. The next step, the counterweights for the individual leaves have to be installed into the bridge. These weights allow the opening and closing of the bridge. The building materials are, once again, steel and concrete. The last time construction work of this magnitude at this site was carried out was over 30 years ago. The building site then, the Rethe lift bridge. What was remarkable about the Rethe lift bridge was that it had been built too big. The span was greater than originally planned, and so ultimately it could be operated at this level into the 1980s. In 1986, they didn't replace the bridge. They raised it by 11 meters. It's the only lift bridge I can think of that has been raised. It was a very unusual step. In 1986, they estimated the lifespan of the bridge to be 15 to 20 years. But thanks to good maintenance and care, it has lasted 10 years longer. But now, an end is in sight. A big one.
It's the
biggest double bascule bridge in Europe, so that's already a special dimension. But what I find fascinating is that despite its vast size, in the end it looks quite delicate. The last leaf is installed. Soon the new bascule bridge will take its place beside the old lift bridge. Until it takes its place, there's still a lot for the HPA team to do. The main focus, traffic flow for those working near the bridge. Residents near the Rethe, of course, have different interests. They all have to be considered. The maximum that was really possible during the construction stage was 14 days in a go, closing shipping so that the bridge leaves could be raised and installed. That was the absolute maximum. Livelihoods depend on the port's infrastructure. The company Saco Shipping by the River Rethe. Like so many companies, it depends on the port's infrastructure. Of course, there are loads of lorries coming in and out. We have the container lorries, and if they can't get out onto the road, it wastes time that they can never get back. Hundreds of shipments a day. Packages of every size. delivered to every corner of the world. In charge of the pallets, Ole Brugmann of the company PCH. He's responsible for all processes in the huge warehouses. Many people are now waiting a very long time before they deliver the goods. It used to be the goods were stored for 1 to 2 weeks. Now the goods arrive and they're gone again in 48 hours. So for us, it's very important to know when the truck is arriving, so that the container's here already. It's all highly coordinated here. Without bridges, the trucks would have difficulty reaching the warehouse. The experts at the packing station allot the arriving loads to containers, which are then shipped from the port of Hamburg all over the world. The carrier that the container has been booked on gives a time limit for loading. So the container must be at the container terminal by a certain time. If it's not there, they are usually unlucky and the container won't be taken. HBA's job is to safeguard the transport routes so that the port can continue to thrive. 2 things are vital for PCH: time and the safety of loads that are shipped throughout the world. It's hard work. We secure the loads for the containers here. All goods have to be secured so that they won't move during the sea crossing. There are regulations about it. We use packing blocks, pallets and air sacs. So we prevent the goods from moving about in the container, getting damaged, or from something even worse happening. So we secure loads here, and the foremen here in the packing plant check the load securing. Never mind how quickly and safely the teams, the pickers and logistics specialists work. The route across the bridges in the port is still the bottleneck. It was already an issue before the Rethe bascule bridge. Bridges are a very sensitive topic, it has to be said. Bridge construction isn't easy. We've got so many of them in Hamburg. When it's finished, everything will be good. But for the meantime, it's not only us at the Rethe bridge having to work under restrictions. Construction works like this are very complicated, but we'll be glad when it's completed, and then we can stop complaining. September 2014. Visible progress. The bridge sections are assembled and operational. The bridge opens and closes as desired. What can the team expect? Construction work on the new bascule bridge is particularly demanding because the bridge is a bit tricky. That's mainly because when the 2 leaves meet in the middle, they must be interlocked. So the whole thing is like a continuous girder. There can't be any wobbling. It must be like it was cast as a whole piece. The most complex part of the bascule bridge project begins: the fine-tuning. The result? Uncertain. There are particular problems with the rail leaves. The challenges wouldn't be so great if it was just a road bridge, because rubber car tires would drive more easily over any irregularities, and they have good suspension. Hard train wheels, though, are much more sensitive. The roads and slip roads are already being built, and you can see progress being made with the railway lines too. Has it all been done as it should be? Any mistake will affect the entire project. A rail bascule bridge like this has never been built before. There's no blueprint, but there are plenty of regulations. There are certain requirements for modern railway systems which didn't exist before, but they do now and have to be integrated into the construction. So everything is even more costly and time-consuming now. The nearer the feeder roads come, the more pressure there is on the bridge-building team. The bridge must be ready. The railway part needs to be signed off by inspectors and experts. A bureaucratic marathon, German style. July 2016. The road bridge is opened for traffic. Despite the delay, it's a reason for celebration. But the hardest part is yet to come. It's not just the construction of the foundations and then the steel structure. Even if all the construction parts fit perfectly, fine-tuning is always needed. This can present challenges that can cause the engineers to break out in a sweat. June 2017. Construction work stagnates. Trains cannot yet travel on the bridge.
Man bekommt dann einen Anruf.
You get a phone call. The situation is such and such, and then you have to adjust the plan by a day or two. There are then the corresponding documents. And by that point, you're in crisis mode. Can the disaster be averted? Have the years of work been wasted? Is the port's infrastructure at risk? The feeling at first was, what do we do? Disbelief, bewilderment, and of course the question of how it would affect the schedule and the completion. The completion is delayed again. No one knows by how long. The railway track has not been manufactured in accordance with the standards. It can't be approved under these conditions.
The
worst-case scenario for the rail bascule bridge is that we don't get approval and that it can't carry rail traffic. The second thing is that we don't meet the tolerance specifications, which means it wouldn't be safe for trains. The culprit, just a few millimeters wide. 2 sections of the railway track didn't comply with the standards once they were assembled. But it has to be said that these custom-made designs like the Rethe bascule bridge are always a challenge. They're individual structures that have to perfectly fit right into the working port, like clockwork. It's much more complicated than simply building a straight bridge in a field over a river. But can the bridge still be opened? You have lots of discussions, you talk it all through, and you work out the best way to resolve it. What countermeasures can be used to rectify the defects? With experience and hard work, they reach a solution. But is it the right one? The missing millimeters are replaced by packing pieces. Are there any other uncertainties? The aspirations are ambitious. In the summer, we're going to adjust the track construction. It should take until around the end of August. Then we'll move into the commissioning processes. Then there'll be tests on the rail bridge. We want the rail bascule bridge to be in operation before the end of the year, so before Christmas. The packing pieces are replaced piece by piece. A few millimeters that bring a 5,000-ton bridge to a standstill. It's an example of the complexity of the biggest rail bascule bridge in Europe, and an indication of the great precision required in bridge building.
Man könnte natürlich die Brücke auch ohne diese Futterplatten.
The bridge could be opened without the packing pieces, but we would soon have to shut down rail traffic to sort out the damage. So trains wouldn't be able to use it, and no one wants that.
Und das will hier natürlich niemand.
The most important thing is to ensure smooth traffic flow in the port.
Wirklich schlimm wäre es, wenn, ich sag mal,
it would be really awful if the new bridge was opened without the second level and it breaks.
Keine zweite Ebene mehr gibt sozusagen und die geht dann.
That would be a real problem.
Gibt's wirklich ein Problem. Deshalb ist es wichtig.
That's why it's important that it really works when it's open for service.
Also man will einfach auf der sicheren Seite sein.
It's best to be on the safe side and take the time to get it right so the bridge is safe to use.
Die Brücke wirklich sicher in Betrieb nehmen zu können.
The pressure on everyone is steadily increasing. Delays are costly, even if the repairs are quick to carry out. No one knows if everything will go smoothly with the mega project from this point on.
Ich hab's nie bereut.
I've never regretted getting the job and having to manage the project.
Machen zu dürfen.
Of course, there are situations when it's more difficult, but I've never regretted it. On the contrary.
Bereut habe ich es nie. Im Gegenteil.
September 2017. All the repairs have been carried out. Now it gets serious. The first train arrives.
Wir werden gleich mit
2 loaded wagons will drive across the bridge at once. We'll simulate various load scenarios. So one slow journey, a fast journey at maximum speed, and we'll also do an emergency stop and reversing to put the structure under as much load as possible. And from that we'll draw our conclusions.
daraus eben unsere Rückschlüsse ziehen zu können.
For the test, the wagons are loaded with over 20 tons of axle load. A huge load. During testing, the bridge is put under much greater loads than it would be in daily operation. The goal was to build a bridge that would operate for as long as its predecessor. Today, tests will show whether that can be achieved. The objective is that this bridge functions under all conditions, so under any load, whether it's traffic load, wagons that cross it, or different solar radiations, wind and weather conditions.
Ja, Wind und Wetter.
And then the test begins.
Okay, also
The train is coming slowly. There's only a small window of time on the bridge. The bridge must be opened for shipping. The team needs to have successfully completed all the tests by then. The first wagon rolls across the bridge. Of course, it would be disastrous if something breaks. So we want to put the structure under maximum strain when it comes to traffic load. We've got the maximum axle load for the structure here today, and we can do harsh stress exercises with them, like emergency braking. That's always an extreme load for the components.
Das weiß ich nicht, das kann ich nicht sehen, aber optisch glaube ich nicht, dass wir über 0,5 liegen. Also das war eher...
Movements are measured with millimeter accuracy. If the bridge moves too much under the tons of weight, it will fail the test. It won't be opened on schedule. The atmosphere is tense.
Die vorläufige Betriebsaufnahme.
A preliminary operating permit doesn't exist for trains. Either there is a permit, everything is in order, or there's not.
Oder es gibt eben keine.
There's no middle way.
Eine Ampel, die hat kein Gelb drin.
Next, they run the test with the heaviest load. Emergency braking with over 100 tons.
Gut.
Achse gerade.
Forwards, and then the same thing again in the other direction. Again and again, the heavy transport goes over the leaves. Does the bridge keep its promise? Millimeters decide whether it will go into operation. All eventualities are considered, identified, and tested. The first evaluation.
Ganz glatt zu sagen, ich finde, es sieht gut aus.
To be honest, I think it looks good. But during fine-tuning, we need to analyze it on the computer, assess the videos, and then we'll see whether the structure has delivered what it promised.
Dem gerecht wird, was sie versprochen hat, sozusagen.
And it does. A few weeks later, the bridge is approved.
Ein Gefühl der Erleichterung.
A feeling of relief and happiness, of course. There's also a bit of pride that you can tick it off mentally. The biggest rail bascule bridge in Europe is operational.
Dass man innerlich einen Haken machen kann.
Incorporated into a transport concept, it boosts the economic power of the port and the region as a whole. The port is 828 years old, and I believe that, as the HPA, we bear joint responsibility with our partners for ensuring that the Port of Hamburg will continue to be operational for hundreds of years to come, and hopefully will never come to an end. 71 square kilometers of port, over 100 bridges, about 300 kilometers of railway tracks. There will be new challenges for the HPA soon enough. But with passion and experience, these will be overcome too. Not far from Rethe lies the Catwick crossing, and the legendary Cule Bridge is already a subject of debate in Hamburg.